I've said all along it's proofs, right? So we are proving, now specifically what we're doing is we're proving trig identities. Okay, now, while yes, there are similarities, because when I say proofs, probably what comes to your brain is geometry proofs, right? Yeah. Because that's where you most recently did proofs. And it's similar, but what I'm going to start us off with is a basic algebraic identity. Because that's kind of the idea. I mean, really, your proof work is start with the beginning, show me the work in the middle, to show me what it is. Okay? So, this is an assignment I mentioned that I grade because it's the middle that matters. It's the middle that matters, that you're not just throwing random steps in there that sounds good to me. No, they have to be legitimate steps. Okay? So, when I talk about this first algebraic identity, the idea here is I tend to just start with the left. We're going to start with x squared minus 1 over x minus 1 minus x squared minus 1 over x plus 1. And our goal, by the time we get to the bottom here, is that equals 2. Okay, so this is often how you'll see me set identities up here. Is I'll kind of, okay, this is what we're going to start with. Your goal is 2 in this case. And it's not to make unpossible things happen. It's to, use legitimate math to make things happen. With that in mind, go back to lesson 5.1. All those identities we used are still available. And those, 5 suggester starter steps are still available. Now, we're talking algebra here, so we don't need the trig identities, but thoughts on what I should do here?
Get common denominator.
Okay, common denominators are good, yes. We see 2 fractions, common denominators, that's an option. What would we do then? Like,
multiply the left one by x plus 1, and then multiply the right one by x minus 1.
Okay. So x plus 1, x minus 1 being our common denominator if we go that way. Now, what is x plus 1 times x minus 1?
X squared minus 1.
It's x squared minus 1. What do you notice about x squared minus 1?
Both of our numerators.
It's already in our numerators, isn't it? So what if I take you a slightly different route than getting a common denominator? And we're going to kind of, well, I guess I can't really call it. We're going to kind of go the idea of a common denominator, but there's 2 ways to get a common denominator, right? Sometimes it happens by like what Logan suggested. You're multiplying by the other denominator. That's our normal way to get common denominator. Sometimes common denominators happen when we are able to simplify fractions. So what I'm actually going to suggest we do, and here's the deal. Could both of these ways work? Yes. Okay, this is still one of these things where there's not just one right set of steps necessarily. So let's take these fractions on the left and let's factor. So x squared minus 1 factors into x plus 1 times x minus 1, correct? And that's going to be over x minus 1 minus second fraction. Do the same thing. X squared minus 1 factors into x plus 1, x minus 1. This time it's all over x plus 1.
Shouldn't we go down for these steps?
Well, so I usually start with my first step over, but then yes, I'm going to go down. Okay, because on the left is just what I started with. What can happen here?
Can you cancel stuff out?
Can we reduce these fractions and cancel stuff out? Yeah, in the first fraction, what happens?
X minus 1 cancel.
A factor of x minus 1 cancels with a factor of x minus 1, and what remains? X plus 1. In the second fraction, what happens? X plus 1 cancels with x plus 1, and what remains? X minus 1. So, in the first fraction, I have x plus 1 minus, in the second fraction, I have the quantity x minus 1. Now what can I do?
Take the parentheses away.
Yeah. And I just put the parentheses there to indicate that we're subtracting that whole quantity. If we take those parentheses away, x plus 1, and then we're going to have what? Minus x and minus negative 1, which is plus 1. Clean that up. What happens? X is cancelled and 1 plus 1 is 2. Okay, guys. That's your proof. We got the answer they wanted us to get. Okay, we started with the left, the beginning. We did official math, we did algebra, and we got it to equal 2. So we proved this algebraic identity. Basically, we proved that the left equals the right. Okay? Now, what do we officially have to do? We have to officially do this with trig. Okay? We have to officially do this with trig. So, on example 2, let's prove the identity. So we're going to prove that tangent x plus cotangent x is equal to secant x times cosecant x. So similar to what we did last time, I'm going to start with tangent x plus cotangent x equals. We're going to do some steps, but my hope is by the end, we're equaling secant x, cosecant x. Okay, now, I'm not going to tell you that you have to go ahead and write this at the bottom, but here's the deal. As you're working through these problems, it is helpful to keep in mind what is your goal. Because sometimes knowing the goal can maybe help you figure out a step along the way. Sometimes it means nothing. Knowing the goal means nothing. You just have to guess at some steps. Okay? So, think about our 5 suggestions from 5.1. And think about your identities. Together we're going to use these. What are you thinking?
Get tan and cotangent both to just sine and cosine, and probably get a common denominator.
Okay. One of our options was changing everything in the problem to sine and cosine. Remember that suggestion? Okay. That's one of our 5 suggestions because we had 2 that were about fractions, right? Well, I don't have any fractions right now. We have one that was about Pythagorean identity, one that was about factoring and FOILing, and we have one about change everything to sine and cosine. Okay, let's try it. Tangent is what? According to our quotient identity, it is sine x over cosine x plus cotangent is cosine x over sine x. Okay, so we've taken that first step of changing everything to sine and cosine. It doesn't really look like I'm any closer to my final answer, does it? We have 2 fractions being added. So what is a good step when you have 2 fractions being added? To get that common denominator and add them, right? Okay. What would be a common denominator between cosine and sine?
Cosine and sine.
Okay, remember, when the denominators really don't have anything in common, we just shove them together, yes? Okay, so my first fraction is going to become the denominator of cosine x sine x plus My second fraction is going to become a denominator of cosine x sine x. Now, and I guess you could, if you wanted to, could you go ahead and make it one fraction right here? By all means, go for it. Okay. First fraction. What are we missing? We have cosine, so we're missing what? Sine. So what are we going to do? We're going to multiply top and bottom by sine x. What is sine x times sine x? Sine squared x. Second fraction. Has a denominator of sine. What are we missing? Cosine. If you multiply the bottom by cosine, multiply the top. What's cosine times cosine? Okay. Now, as I put this together, I have a common denominator, yes? We have two fractions with a common denominator. Common denominator goes together. So cosine x sine x, my numerator is just going to be rewritten as sine squared x plus cosine squared x. Why is it equal to 1? Okay. One of our Pythagorean identities, right? You still are flipping back to that page as you need to. One of our Pythagorean identities is 1. Now, I'm going to write this a little bit lower because I'm running out of room. So, knowing your Pythagorean identities is good. So, this is 1 over cosine x sine x. And, guys, you don't need to write yourself any notes. But if it helps as you're going through, you don't have to label your steps. This isn't geometry. I'm not requiring you to give me the reason why you did this step. But if you want that helpful bit of your own, then by all means do that. Okay. Now what? I lost my goal because I ran out of room there, but
There you just flip it.
you guys understand what he means when he says just flip it? What do we know about a cosine in the denominator? It's a secant in the numerator, yes? What do we know about a sine in the denominator? It's a cosecant, yes? Now, can you go straight from this step to the final step?
Yeah.
I am perfectly fine with that. Okay? If you are hesitating and saying, what, Mrs. Sargent, I'm not quite there, then here's what you can do if it helps. Break this into two pieces. This is 1 over cosine x times 1 over sine x. Yes? If you need that visual right now while we're in this learning process, I just took cosine and sine. They're being multiplied, so I split them up. 1 is 1 times 1. But now realize 1 over cosine is secant x. 1 over sine x is cosecant x. Did we make it? Yeah. Does it sometimes help knowing what your end goal is? I think it does. Okay, so now keep in mind all that simplifying we did back in 5.1. It should have helped you at this point, right? All that simplifying we did should have, be setting you on the right track. Now, okay, in terms of steps here, guys, when I grade this, I'm looking for appropriate steps. Don't make me guess how did you get from point A to point B, because I'm not going to give you credit. You have to make me believe you knew what you were doing. Not make me believe that, well, it looks like they were just filling in some gibberish to make it look like, what was supposed to happen. It has to be legitimate steps. Now, in terms of what I would expect to see here, first row, definitely. I would expect to see sine over cosine plus cosine over sine. In terms of second and third row, would you have to write it as two separate fractions first? Could you jump to that third row and go ahead and put it together as one fraction? You could. I would be fine with that. Now, if that doesn't work for you individually, Would you prefer to do two fractions first? That's fine, okay? In other words, kind of one of those rows would be fine. I need to see that we went to a Pythagorean identity, that we went to 1 over cosine sine. Don't just jump from right here, where we still have sine squared over cosine squared, to final answer. I'm not going to believe you knew what you were doing. I'm going to think, you didn't know what to do next, you just put the answer. Okay? Make me believe, right? And so 1 over cosine sine. Now, could you just go to the final piece from there? Most definitely. So there's some things that I put up here you could skip. But don't skip too much. Okay? If I have to question if you knew what you were doing, you skip too much. Okay. Let's look at number 3. Prove the identity. So, I'm going to start with 1 over secant x minus 1 plus 1 over secant x plus 1. And my goal is that hopefully by the end, it will equal 2 cotangent x cosecant x. I will say, you can always work backwards a little bit too and see if that helps. If you hit a stuck point. Okay, guys. What are your thoughts here?
Common denominator.
Okay. Last time I said common denominator was a good idea, but I also showed an easier way of factoring and canceling, right? Is there anything to factor on top and cancel? No, it's 1 over these. So common denominator is about the only thing I know. Good thing is, though, I like getting a common denominator because these two are what I call conjugates, right? So, with this in mind, what is my common denominator going to be?
Secant squared x minus 1.
Okay.
Oh.
Yes, I'm not writing that yet. I agree. I'm writing it as secant x minus 1 times secant x plus 1 for the moment. And I'm going to go ahead and write it out as 2 separate fractions for the moment also. Secant x minus 1 times secant x plus 1. If I write too many steps for you, be happy you know what you're doing. Okay? First fraction. What do we know? We had secant x minus 1. What were we missing? Secant x plus 1. So what are we multiplying the top by? We're going to multiply by secant x plus 1, yes? Big math here. What is secant x plus 1 times 1? Secant x plus 1, yes? Second fraction. We have secant x plus 1. What are we missing? We're missing the secant x minus 1, right? And 1 times secant x minus 1 is secant x minus 1. Okay. The whole point of getting a common denominator is what do you usually want to do next? Combine your fractions, right? Add them together. Now, you can go ahead and multiply them, or you can wait a step and decide if you want to. You'd be safe to multiply them here. So there's my common denominator. What happens when I add these numerators? Secant x plus secant x is going to be 2 secant x. And what about the 1's? 1 plus negative 1 will cancel. Okay. Now, what are you thinking? Is it a good idea to multiply my denominator? The fact that secant x minus 1, secant x plus 1 are conjugates is good, right? So if you haven't already, let's multiply those. 2 secant x on top, on bottom. Secant x times secant x is secant squared x. Outsides, secant x times 1 is 1 secant x. Insides, negative 1 times secant x is negative 1 secant x. So what happens with my outsides and my insides? They're going to cancel. And then last, minus 1 times positive 1 is minus 1. Okay. Thoughts? What?
The bottom tangent squared.
Is the bottom tangent squared x? What's he referencing? Yeah. We have a Pythagorean identity that says 1 plus tangent squared x equals secant squared x, yes? Same thing I said back in 5.1. When you see squared functions add or subtracted with other squared functions or ones, what should you consider? Check them out, right? And I saw multiple people looking back there. So, yeah, subtract the 1 over. Tangent squared x is indeed equal to secant squared x minus 1. So we are going to do that substitution. So I have 2 secant x over tangent squared x. And here's my thing, guys. In the end, I'm getting down to all stuff being multiplied together, right? So I know I'm not going to want adding and subtracting my problem. I know I'm going to need to somehow make that adding and subtracting disappear. Thoughts of where to go next? Huh?
That's as far as I got.
That's as far as you got.
I mean, we know that 1 over 10 squared x can become 8.
Yeah, it's 2 over 10, so it would be like, we've got it and the tangents.
But it's
Square.
tangent
What
squared.
cotangent?
I don't know.
Yeah, I don't know where cosine comes from.
Okay. Well, here is, somehow or another, here's my suggestion. We somehow, like, you can see a little bit, right? That, like, okay, tangent squared could, or tangent can become cotangent. Like, tangent in the denominator can become cotangent up above, but we've got a squared there. Somehow or another, these all translate between sines and cosines. So my suggestion would be to change everything to sines and cosines and see if you can rearrange things to make cotangent and cosecant happen. Does that make sense? Okay. Now, how are you doing this? I'm trying to decide how I want to write this out.
So, you can probably start it with like 2 over cosine of x, and then over sine squared x over cosine squared x, and then you can like keep change flipping.
Okay.
That's what I
Okay, we got that.
How fancy are we? Can we keep, change, flip as I go and not have to, or is that going to be too? Okay. So 2 is 2. I'm just even going to put the 2 out front. What do we know about secant? Secant is 1 over cosine x, right? And you could now, I think someone said 2 over cosine. Could you put it as 2 over cosine as well? Yes, I was just trying to separate the 2 out. Tangent squared is sine squared over cosine squared, right? But if I keep, change, flip, sine squared over cosine squared, it becomes cosine squared over sine squared. So from right here to right here, that was a keep, change, flip, yes?
Yeah.
I don't know, maybe I shouldn't have done that, but. Now, what do you see that can happen here? A cosine can disappear, yes? Okay. So let's make a cosine disappear. 1 cosine on bottom cancels with 1 on top. Now think about what you have. You have a 2, yes? What do we have left? We have a cosine over sine squared. How could I rewrite that would be helpful in getting to our final step? Do we have the right pieces? What do you know about cotangent?
Cosine over sine.
Cotangent is a cosine x over sine x. What do you know about cosecant?
1 over sine.
It is a 1 over sine x. What just happened? I took my cosine over sine squared and I split it. I made it cosine x over sine x and I made it 1 over sine x. Does that work? Because what just happens? 2 is 2. What's cosine over sine? It's cotangent. What's 1 over sine? Cosecant. Did we make it? Now, right there is a perfect example of, I made the comment earlier, it's sometimes helpful to know what our final goal is. We needed to know the final goal there, didn't we? Because otherwise I didn't know how I was going to express my answer. Okay, so knowing the final goal is definitely helpful. Because I kind of could look at the end and kind of work my way backwards a little bit of how do these cosines and sines connect. Okay. Okay. Ready for the next one? Cosine t over 1 minus sine t equals 1 plus sine t over cosine t. I guess I could go ahead and I didn't set it up, did I? Hopefully you're thinking about what you should be doing. So we're starting with cosine t over 1 minus sine t. And our goal is to get to 1 plus sine t over cosine t. Now we're doing t's. Earlier we did x's. Sometimes we do thetas, u's. Well, my suggestion is I always encourage you to try and use the variable they give you. Okay? Now, maybe I shouldn't be, but I don't get too nitpicky, you know, if variables, you know, you accidentally work in terms of x instead of t or something. But, okay. Do we have an idea of where to go on this one?
No.
Set equals 0.
Can't do that. My goal is to prove the left equals the right. There's no setting it equal to 0 things.
Yeah, I just realized that. Yeah, that. I don't know. Let's go.
And it would be great if that was 1 minus sine squared t.
Yeah.
Then I might have a place to go, but you guys caught it. There's no squared there, so we can't think Pythagorean identity. Okay, I'm going to throw something different at you. Because you're right, we don't really have a place to go. There's no Pythagorean identity. It's already in terms of sines and cosines. Like, there's just not a lot of options. So one of the things you will sometimes see is taking your denominator of 1 minus sine t and multiplying by the conjugate to give us a direction to go. What do I mean when I say conjugate? Okay, that did not erase. Conjugate.
1 plus sine t.
So we're going to multiply this denominator by 1 plus sine t. And you guys know enough to know if I multiply the denominator by 1 plus sine t, we're going to multiply the numerator by 1 plus sine t and see what happens. Now, on top, I don't know that I would multiply that out. I mean, I would consider multiplying it out, but I don't see anything to be gained from multiplying it out right now. So I think on top, I'm just going to leave this as cosine t times 1 plus sine t. Can I go in and distribute it later on if I decide it's necessary? Yes. Now, the denominator. Okay, guys, I've said this before. They're conjugates, yes? If I'm multiplying conjugates, I do probably want to multiply those. There's usually, good stuff happens when you multiply conjugates. So what happens when I multiply my denominators?
Becomes 1 minus sine squared.
Yes? 1 times 1 is 1. They're conjugates, so outsides and insides cancel. Negative sine t times positive sine t is minus sine squared t. Now what? What'd you say?
Yeah.
Now is there a Pythagorean identity that works?
Yeah.
Yeah. We have a Pythagorean identity that is sine squared x plus cosine squared x equals 1. So I can subtract the sine squared over and make this work. So cosine squared x equals 1 minus sine squared x. And folks, when I do this side work with Pythagorean identity, you don't have to prove it to me. I know that what Pythagorean identities will equal each other and stuff. This is just me trying to make sure everyone sees it. Okay, so my numerator is cosine of t times 1 plus sine t. My denominator now is cosine squared t. Now what?
Just cancel out the top one and cancel out the square on the bottom. And
1 cosine t on top cancels with 1 cosine t on bottom. And I now have 1 plus sine t over cosine t. And
Bam.
we're there. I rewrote where I'm supposed to be at, but we're there. Okay, so that's a trick to add to your toolbox of multiplying by the conjugate. Okay, that's a trick that works in algebra trig, works, several different places. We use it when we are trying to rationalize and we're trying to get square roots out of the denominator. We use it then. So you've used that trick before, but that's a good one to hold on to. Okay? And
Looks like a problem for another day.
it is a problem for another day because we are not getting through that one that quickly and easily. Let's just say I used that entire part down there.
You right.
And I sometimes put too many steps in. So,
Like, I don't write
Fair
out
enough.
all the PIs and all that.
Okay, guys, tomorrow we'll work on that problem. And then you should have some work time tomorrow. And then homework will be due Thursday.
Shit.